We are Project 23102, the metallic mine design competition hosted by the Society for Mining, Metallurgy, and Exploration. Our team is comprised of 6 mining engineers: Alex, Ben, Sebastian, James, David, and Katie. This is our design day poster. We will now go more in depth into the competition and our designs. The SME Metallic Design Competition is a 2-stage hard rock competition focused on the evaluation of a mineral deposit and the development of a potential flow sheet and process design. In phase 1, teams had 3 weeks to develop an in-depth plan for a pushback for an existing mine. This included designs for the mine itself using a mine planning software, operations, processing, tailings, economic analyses, risk analyses, and environmental, social, and governance considerations. The report was then submitted to SME for judging. The top 6 teams internationally moved on to phase 2 of the competition, where they had 48 hours to solve an additional problem. This year, we were tasked with redesigning the mine's molybdenum processing circuit.
Okay, so for phase 1, we were given data and asked to expand an existing mine, and that mine was located in Brown County, Arizona. So we were given some geology information, which we were then able to import and create a electronic model, which we created using 3 different pushbacks to mine the remaining ore. And then from that model that we created, we were able to write a overall mine plan report, which was a high-level solution to a couple different areas: environment, permitting, geology, site design, processing, operations, and economics. We put that all together in our final report, sent that to the judges, and based off of our performance on that phase of the competition, we were selected as one of 6 teams internationally. We then moved on to phase 2 of the competition, which we were asked to put together a solution for redesigning the molybdenum processing of the operations.
Our ore mined during the first 3 pushbacks are sent to our processing plant to liberate the saleable minerals from the host rock. The first step of this process is to reduce the particle size, which is done within our grinding circuit. This crushed rock is then separated into ore-bearing minerals and waste rock via flotation, the process in which 2 different minerals are separated based on their hydrophobic properties. The extracted minerals are then sent to the rougher circuit to separate the molybdenum from the gold copper concentrate. From there, this copper concentrate is then sent off to smelters to produce saleable copper. In most plants, the molybdenum concentrate is simply dried and sold to outside sources for further processing. In our plant, however, the concentrate is sent to our 4-stage flotation circuit to further increase the grade of the concentrate by pulling out and recycling the remaining copper within the concentrate. With the copper removed from the concentrate, we further increase the grade with the use of vat leaching via hot ferrochloric acid, which finally, with our high-grade concentrate, we utilized a looping sulfide oxidation roaster to produce our own saleable molybdenum.
After the vat leaching process, moly disulfide is processed at the looping sulfide oxidation roast. At this step, either moly dioxide or moly trioxide can be produced based on market demand. The roaster will be operating at an average temperature of 800 Celsius degrees. Through LSO, minimal energy is required due to its autogenous exothermic nature. Also, the sulfuric dioxide off gas is treated at the acid plant to minimize pollution.
All right, so one of the big tasks when looking at the feasibility of a project like this is to prove profitability and then to optimize our net present value. So we conducted a pretty in-depth economic analysis of the project, and our overall after-tax cash flow was about $6.7 billion. And then that rendered a net present value of about $4.8 billion on the project. So that was great to see, plenty profitable. Further, we did sensitivities for our net present value to see what the biggest drivers would be in change of that NPV. Our biggest is going to be metal price and metal recovery. Both of those lines nearly overlapping each other. We can see it on this chart, starting in the bottom left, trending up to the right. And then our operating cost was another big driver. That's going to be that blue line that we see trending down to the right. Not as big a driver as price and recovery, but still fairly substantial. Then as far as the feasibility of our in-house roasting facilities, we did another analysis there. As we can see on the left side of the chart, in 2023, we have a little over $10 million in capital expenditures for the facilities and infrastructure to get that going, so we can do the in-house roasting. The cost of that is represented in that green line running across the chart there, and then our blue bars show our savings as a running total of doing everything in-house. So we can see our break even comes in about the year of 2028. And then after that, it's just anything above that green line is our savings as the project moves on.
To summarize our results from the design, finding the most economical time to redesign the molybdenum plant was one of the main concerns in phase 2 of the competition. By redesigning the plant in 2026, the mine will save over $10 million relative to redesigning the plant immediately. We also opted to design our own LSO roasting facility on site to save costs on shipping the ore to a roaster offsite. The mine is designed to produce around 50 million short tons per year of copper ore and is expected to have a net present value of $4.8 billion. The pushback design in phase 1 will extend the life of the mine by 6 years, ending in 2021. Overall, our team finished second internationally at the SME Student Metallic Mine Design Competition after presenting our design to a panel of judges. We're all industry professionals, and we also had the highest scoring report in phase 1. I'd like to quickly thank our sponsors, Hexagon and Stantec, for their support and for funding our design team. Thank you for your time and attention. We're very grateful to have this opportunity to share our project with you.
Good.
Sweet.